Our next talk is from Tenaga Nasional, and our presenters are Rosalina and David from Calibr8. So welcome to the stage.
Hello, everyone. I hope you guys have good lunch and a quick break just now. My name is Lina, a shorter name from Rosalina. Lina is much easier to remember. And I'm here with Mr. David. I'm from Tenaga Nasional, a power utility in Malaysia. So today, we'll be sharing a little bit about our little project of having to build a custom symbols of Duval's triangle, centrally in the Pi visions that we've started around 3 years ago. Okay. I'm going to stay behind the podium anyway. I'm obligated to share a little bit about my organization because they pay for my mileages here. So basically, Tenaga Nasional is a main power utility that a vertically integrated power utility companies in Malaysia, responsible in generating, partly generating because we have IPPs, independent power producers, transmitting and also distributing electricity. And if you haven't heard about us or the country, yes, we are located between Thailand and Singapore, the small peninsula there. So I'm specifically coming from grid division. Before this, we were known as the transmission division. I'm a solution architect for a digital OT environment. So I basically specializes in the OT environment, the ICS, the SCADA system, and all those fancy engineering systems. It started off the reason because we embark on our digital transformation services. I'll be basically sharing the vague high-level architecture processes of our digitalization, and David will be sharing all the good stuff later, all right? So it started off, the driving force behind our digital transformation was because of our system operator was being ring-fenced. So there's a clear need for us to segregate the operations and the maintenance aspects of the asset. That was the main reason. And given that the system operator, what we call them as GSO, they are basically slightly independent now. So they would like to concentrate only maintaining the operations alarms. And the asset, the maintenance of the asset, anything that with regards to the asset alarms will be handled by grid as an asset owner. So that was the driving force. So 3-4 years back, we basically, a bunch of us sat together, cracks our head on how to basically segregate the data going into the master system and how we're going to get it into the different environment. For the OT enterprise, we call it. Because conventionally, all the data basically goes up to the RTU and it goes up to the EMS after it has been processed, and then it goes back to the other users. So there's a slight delay of probably 30 minutes in terms of replicating the data across multiple segmentations of network, and then different databases that cut across master system into the enterprise layer. So that was the strategy. We wanted to make the data efficient. So, and the other way is for us to move away from the conventional ways of doing application-centric approach to more data-centric approach. Because along the ways that we have experienced in our grid operations is when there's a primary people going to install an OMS into their primary equipment, like transformers, they'll do it themselves, they get the sensorization going on, the data coming out, but it stays within their environment. So it's very silo. And then the secondary guys come in with their CVTs, transducers, and it stays within their environment. So the idea is how we are able to basically consolidate the data. So that is our data efficiency strategy. Once we have all the data coming, sending over to the central storage, the historian, so we are looking into the operational excellence. Basically, you're talking about, simple tweak, because these people are already great at what they are doing. They're already good at it. Even with less visibility on the data, they are doing really well because our system minute is very low. So what they were trying to help them with into the operational excellence is we are being very cautiously optimistic in our approach. When we approach our users, let's say that we would like to basically just automate whatever mundane activities that you have. Trying to create an automating reporting dashboard. So by having to do that for our users, we are creating basically less man-hours serving routine repetitive tasks and free them up for more innovative things, more higher value worthy stuff to explore. So those are our vertical strategy in terms of our digital program. But we have that vertical strategy. We require a horizontal strategy. So we require a vertical execution. So in a very cliche manner, in any digitalization platform, we have formed 4 pillars that looks into the specific areas, and we have elected what we call a champion in order to work to identify the gaps that exist in their process, what are the digitization, digital effort that they require in order to optimize and perform better. So while we get the data in, all the leaders will come up with the multiple initiative so that whatever data that they have, they can immediately use. So horizontal strategy, vertical execution. So while we were looking into how we can work with the leaders, because I'm coming from the digital OT team, so I don't have the use cases. I have data, right? So I will be engaging. Usually what we do, we engage our users. Right now, the one that I'm sharing with you guys is the one that is under the pillar of intelligent asset management. So we are looking into how we are able to help them to improve their return on capital and optimize asset reliability. So I'm going to touch a little bit on this. I'm not going to basically read up the slides. So we are looking into while we are having all this data efficiency program, basically a fancy way of saying that we put, describing, actually what we are doing is we put a gateway inside our substations, connect it to all the possible data acquisition devices, and bring it up to our historian. So while we're doing that, there's a whole lot of parallel sensorization programs that is ongoing. Specifically, right now, I'm touching on the OMS. So as you know, transformer OMS, specifically on DGA, is always vendor-driven, whereby they come in, install the whole package from data acquisition towards having to basically provision the platform, the UI, UX, the analysis engines and whatnot, but it stays in a silo manner. Those UI, UX will be able to be remotely accessed individually from corporate layer, right? So you have these fancy things that would actually be able to give you results and the performance of your asset, but it still stays silo at the downstream layer and accessible via corporate layer through only remote access. So this is basically what we have talked to our users, and we figured that there must be a way for us to basically bring all the data centrally, one. Secondly is to consolidate the views of all the fleets, regardless of whether it is equipped with OMS system or the less critical asset of transformer that don't have OMS or only basic monitoring measures. So let us see how we can actually improve your view and how we can create that monitoring dashboards with notifications and whatnot. Because the weaknesses of having to basically deploy OMS system at the substation level is, one, without having to utilize the telco services, SIM or anything, there would be a segregation in terms of the network itself. There's no conversion between the OT and IT environment. So notification is usually sits in the enterprise layer, the corporate layer. So there's no way for them to get the notification out to users. So the one thing that we help them with is, once you get all the alarm signals into the PI system environment, we will be able to emulate notification centrally. we solve one problem for them. So the second one is, it looks as if like it's a repetitive nature or it's redundant. From all the raw data that we have collected from the OMS, together with Calibr8's help, we are rebuilding that particular analysis of Duval pentagon and triangles. Triangles, right? Sorry, I'm very poor at engineering. So we rerun a benchmark analysis of all the OMS that has been installed. The reason why is, one thing, we would like to secure the remote access only to those who are authorized to use it. But other users are not going to be able to gain that kind of access, right? So we are opening up that particular visualization to more users by having to build everything centrally. And you are able to basically scale up this particular approach in a manner that although those that is without OMS rich man approach, the expensive OMS sensorization program, would have a similar level of analysis being drawn up for a less critical transformers. So that is exactly what we're trying to achieve. So this is basically the things that we're trying to resolve for our users. We are very lucky because when we started this, although I'm considering ourselves to be very late in the game, because we only started to look into Pi system only around 2019, about 3 years ago, right before the pandemic. And we started off with the AF engine coming in. So there's no migration of process book. We started off basically at the latest version that they could offer. So the best that we have, what we've learned from presentations, that publications from you guys, we realized that yes, although we are new, but we understood that there's a need for a standardization of naming convention that cut across all 450 substations in Peninsular Malaysia, covering 500, 275, and 132 kV substations that we have, 500, close to 500 now. Standardized naming convention. We are utilizing IEC 61850 asset management data model in our AF. So we have basically standardized the template of all the possible assets that we have. Everything is quite clean, quite efficient in terms of basically exposing and giving the data out to our users. So we come up with this architecture where the SDII, we really love acronyms as well. SDII is basically Substation Digital Intelligent Infrastructure. Like I've mentioned before, a fancy way of saying we install gateway at the substation site. And then from there, we create what we call an ecosystem of a grid digital intelligent infrastructure, comprises of the time series data coming from Pi system. The other one is actually the data lake, where we have multiple instances of transactional database being entangled there for opening up. So this is what we call freeing up the data, democratization of the data. So all the small application, even our SAP is now residing within our data lake, and we are able to basically connect our AF to the data lake, and we are merging a time series data and a transactional business data for our users' point of view, one consolidated view. So, well, that's all from me. We are working closely with Calibr8 because I'm the data person in our division. Then we actually have hired Calibr8 to help us get the symbols in, because Pi Vision standard, they don't have these symbols. You have to manually custom it because we are still starting. Our knowledge base is very low. That's the reason why we hired them. They have been a great help. But the architecture that you saw is because we have started to design it even before OMS or Calibr8 came in. So they work with whatever that we have. But Calibr8 will actually tell you what are other measures and other ways that they could bring the data into your environment. It doesn't have to be this way. All right? Thank you, guys.
Thank you. So good afternoon to everybody, and thank you, Ms. Lina. So Ms. Lina already has told you the why we are doing this. So I'll show you the how, so hopefully. But if you want more details, we have a booth downstairs. So what we have done so far is actually custom symbols in PiVision. As Ms. Lina explained, it's really about putting a lot of algorithms in AF, Asset Framework, but we develop in partnership with them as well. It's a close collaboration, and also we have also worked with Michel Duval himself to confirm all the algorithms. So we develop the symbols within PiVision. But please note also that being in Asset Framework, we've also developed rate of change. As mentioned by Ms. Lina, there's online and offline as a data collector. So I'll show you what we have done so far. So first we connect what we can connect. Those are the online analyzers. Then we also do offline. We have data loggers. I'll show you more about the data loggers. But very critical now is really the Asset Framework. The algorithms that we put into the Asset Framework prior with developing the custom symbol. So we've worked a lot on this one. Again, it's all about collaboration. We know Pi, but Tenaga is the subject matter experts, of course, in transformers. The other ways to actually get the data, we have this saying that there's supposed to be no excuse in getting the data. So again, online DGA via Pi interface can be done via OPC or Modbus. For offline, we can get via manual loggers, web-based, or actually we have done in other clients as well, connect the serial ports directly and convert it into UFL, so that's directly into the Pi data archive. For offline, really offline loggers, we have worked with them in developing Google-based or even Excel-based spreadsheets and logins. But the cool thing that they've asked us to do as well is they have third-party chemical oil sampling and testers. The results are in PDF. So they want to automate it because imagine all the 500 substations and transformers. They need to actually collect the data and not having mistakenly put in the data. So using optical character recognition, the PDF format is pumped into the application. Then we get the data into the Pi data archive. So once we do it, all the displays are refreshed automatically. So of course, we have to do one-time customization based on your PDF file, but it's just one time. Moving forward, so the challenge really is about the data are in silos. I think you know best that most of the time we keep the data to ourselves, but the solution really is about data sharing, collaboration. With the Pi system, it's now in one central repository. So they could now actually, since they're the subject matter expert, they could now see and analyze their transformer health from an automated and offline. So because some of the transformers are sampled once a year, twice a year, then comparing it to an online DGA, now they actually have a standard display across and gives them independence or empowerment of the users that all the data is being shared. So business impact, again, we feel that it's really empowering the users, giving the data to the users. So it's really about collaboration. When we say cost effectiveness, because it's not dependent to any third-party vendor, it's really a collaboration. We did it together. We just don't did it ourselves. We did it with Tenaga. And future-proofing because, again, there's no excuse in getting the data. There's no dependency on type of transformer or vendor. They could now buy or implement commission any transformer that they want, any brand. The users have a standard way of getting the data, and actually we have a standard in publishing the data as well. So what's next? These are all in discussion. It's really more data. The more data that actually go into the Pi server, the more accurate, the more correlation that you can get, the more accurate you can get for the transformer age and actually transformer reliability. We're now going to test some integration with thermal cameras. So you're getting all the data from your RTUs, online DGA, manual loggers. We're now combining it with thermal so that they would really know before sending engineers. We're also working on putting other data sources into the Pi, like we're working with Cisco and Comtrade, PMU data. So again, the more data, the better. And again, it's really a collaboration between Tenaga and Calibr8 and their subject matter experts. Lastly, again, we have a saying, everything starts with data. If you cannot collect the data, you cannot actually analyze. So that's it. Thank you very much. So please let us know. Thank you.
Nina, you got to get back on stage. No, stay there. Do we have any questions? Nina?
You can direct all the questions.
You can't get out that easy. Here we go, right here. Hang on.
Yes.
We're good.
Sir. No problem. Hey, Adam Shapiro. I'm with the New York Power Authority. Just a question for you about the custom symbols, and if this is too technical a conversation for here, that's fine. How did you guys go about building that? You know, I know we look at stuff all the time where we're trying to figure out how we can make, displays that look less, look less engineering and more like something I could share with operators and stuff.
Yes.
Was it a difficult process to do those custom symbols for the Duvals, or did you find that was something that you got off the shelf that you were able to bring in?
Well, maybe the answer is yes and no, because it's easy because we can really put all the algorithms first in AF. Then it's a matter of the Pi SDK and developing it. So the good thing is, meaning maybe us, the team, are very good. They have knowledge on the AF and they have development skills that we can put into Pi SDK inside the Pi Vision. It's really just a matter of playing around with it. We have a booth downstairs. We could discuss with you further on how we can build the custom symbols.
Oh, perfect. Thank you.
Yeah, and I'd like to add to that a little bit. Sorry. So Vision is HTML5. And there's all kind of libraries and stuff. You can get spider diagrams. You can get all kind of stuff that you can add to the library type of thing.
I wanted to say that as well. There's a whole lot of free charts providers out there. I can give you one, is M-Charts. Usually, we bring the symbols in. There's a set of libraries and the mapping that needs to be done in order to get the data to be mapped to those charts. It's just a simple AngularJS or .NET capabilities. It's actually quite easy. Now that I've learned from them, it's quite easy. When we first started, it was very confusing. Yeah, it's very simple, actually.
No, excellent.
And make sure that any extension that you're using goes through a little security check a little bit as well, so you don't open up Vision to maybe a security hole.
You would like to see there's a cross-scripting capabilities, because when you load something free, usually goes back to that providers. So you don't want that kind of security issues within your environment.
Yeah, I don't think our IT department would let us do that anyway.
Yes.
But you can actually write your own widgets and stuff, or use someone like Calibr8 that already knows how to do it.
Yes.
Excellent.
Less headache for us.
Yeah.
Thank you.
Thank you.
Any other questions?
Yeah, Vincent Fry, California. So you had mentioned a Google Sheets add-in.
Yep.
Is that your proprietary one, or is that an OSI Aviva product?
We built it for them.
Okay.
So we got it both in Excel and Google. So we can share with you.
Any more? Yep, one more.
Hi, Gaurav from Con Edison. How challenging is it to maintain this custom symbols when you upgrade the Pi Visions, like, OSSoft, I mean, these guys keep on upgrading the, like, let's say you developed something on Pi Vision 2020 and then you upgrading it to 22.
Right, maybe I can answer these questions on behalf of, because he's the CEO anyway. Because the libraries is dependent on the .NET framework, the frameworks of the development that you use. If the Pi Visions is running on the higher versions of the of a framework, .NET framework, So you need to look into the what do you call it, the version of that particular charts that supports. Usually it goes for 3.5 to 4.6 or 4.6 and above. So it will be able to hold off for a few years before it gets an update. But once you have everything in, usually the providers will give you a higher versions, a compatible higher versions. It's just a matter of basically transferring the libraries in, but everything else would be intact. Right?
Thank you.
Thank you, Ms. Lee.
Thanks, guys.
Right. Thank you.